Did anybody notice my screw up from last time? So here it was, right? Here's what I originally had. Return x minus y. Well, what is x and what is y? Those are the pointers to the integer values, the zip codes, not the actual values. So go ahead and dereference them, and then you get the values, and then you can do the difference trick. But the difference trick is still bad. Right? Remember that it is susceptible to overflow, underflow, and also if you're okay in some regards because these are zip codes and they're only 5 digits, and so you're not going to risk overflow or underflow. But if these were doubles, it'd definitely be completely wrong. If these were unrestricted integers, this would definitely be susceptible to overflow, underflow. So you definitely want to write full if-else-if statements. All right, so let's do that. If dereference of x is less than dereference of y, then return something positive. Or sorry, negative, because they're in order. This is going to be an ascending order. Else if dereference of y is greater than dereference, or x is greater than dereference of y, return 1. Another common thing that we're seeing is people aren't following the pattern that I've been following of making sure that the equality is always the third one, right? Getting into that habit will save you a lot of headache if you ever have doubles, floating point numbers that are very, very close, right? Hopefully I didn't screw anything else up. This is exactly what we had last time. We didn't do it with strings, and we can't do it with strings. It's not this simple. If you want to read the book, my book, and it goes into why this is. At one point, I drew an entire page full diagram of what happens behind the scenes for why this is not going to work, right? But in any case, I don't want to beleaguer that here, right? What we've got is we open up the zip codes, and we are opening up the test file right now, which is only 18 of them, right? And then we sort them in order of this integer comparator here, and then we print them out. So let's go ahead and make sure that works at this point. And run it. There we go. So indeed, it is now finally sorting. Right? Remember that we're not doing that leading 0 there, but we can if you want. Right? So do you remember %d? Oops. There we go. Now it's printing out a leading 0 here. Right? Let's walk through that. Right? This prints out a minimum of 5 columns because it's a 5-digit zip code. Well, it'll only pad it out over here with spaces. So if you want to pad it out with zeros, you can actually put a 0 in front of that, and it'll pad it out with a bunch of zeros. Right? Okay, so let's finish this up. Now that I've got it in this order here, how would you go about counting these up? Well, if you see a zip code, look at the next zip code. If that's the same one, if that's different, then you're done, right? You've only counted this one zip code. Otherwise, if you get down here and you see this first zip code for the first time, and you look at the second one, oh, and it's the same. Okay, I've seen it once. Go on to the second instance. Look at the next instance. Oh, now I've seen it twice, and I need to go on to the third instance. Go on to the third instance, and you see the next one. Oh, I've seen it 3 times. Go on to the last instance in which you count it for and then report it. You don't have to worry about anything prior to it. You don't have to worry about anything after it because they're all right there. So let's go ahead and write that loop to do this. I'm going to do it in this loop here. Right? So let's go ahead and capture that current zip code, which is going to be zips savi. There we go. Right? Now, I'm going to look ahead and see if the next zip code is equal to that zip code. Okay. How do I do that? Well, if the current zip is equal to zips sub I plus 1, right? Then I need to increment, counter, and go to I plus 1, right? Now, obviously, I don't want to do an if statement here because I don't want to look at just the next one. If I've got 4 zip codes all the same, what kind of a control structure do I want right here instead? A while. Why'd you immediately go to a while loop? Did you know up front how many zip codes are going to be like that? No, which would be appropriate for a for loop, but we don't know that, so a while loop. While the next zip code, this is the next zip code, while the next zip code is equal to the current zip code, increment a counter, right? int count. We'll come back to that. I don't know where to start it. But then we'll go ahead and increment the counter, count plus plus, and then go to I plus 1. Well, we can go I plus 1, I plus plus. Right? Now, we're inside a for loop here, but you can still do that. Right? You can still manipulate any variable that you want. So this will jump ahead, and then the for loop takes care of the overall structure. All right? At the end, let's go ahead and report it and see if it works. Printf %005D, and that appeared how many times? %3D. We'll go ahead and do it like that. And the line, the current zip, and the count. Okay? So tell me, where should I start the counter? Let's think about this with a zip code that we only see once, 33992, right? We see it here. How many times have I seen it? Once, right? If we do not see that zip code subsequently, we'll never execute this loop. So am I reporting it correctly here? Yep. Now, I'll cross my fingers here and see if we're actually reporting these 4 correctly. Let's go ahead and compile it. Run it. There we go. 64886. Okay, that looks like it works. 4, 1, 2. How could you make absolutely certain? In fact, let's jump immediately to our 10 million test case. Right? Remember I told you that this would probably take a very, very long time with that naive solution that we first tried of going through it once for every single zip code. So 10 million times 10 million, they call them 100 trillions. Right? All right. It still did a lot of data, some data processing there, but it basically got through it really quick, right? It was probably, the vast majority of the time was actually probably loading up the file. And then the actual computation took a blink of an eye. And then dumping it to the output, that took a little bit too. How do we know that we're correct? Am I going to open up that file and look for 9999 or 4 nines and a 0 and count up the number of times I see it? Not with that test case. So this is where tools come in. We briefly looked at how you could do things with regular expressions, right? Well, that was in a text editor. You can actually do that from the command line using grep. GNU's regular expression. I want to search for, I don't know, 99990 in the file zipcodes.test. Right? Oops, not test. 10 million. There we go. Okay. It found it that many times. Right? Okay. That's remember this number for me. My program says 96. So now all you have to do is go through in there and count 96. Right? Are you going to do that? Nope. I'm going to pipe this through another program called WC, which I think we've talked about before. Word count. And I'm going to tell it, count the number of lines. This is an extremely common occurrence that hopefully if you take CSCE 251 next semester, it's an online Unix course, 1 hour, right? You'll go through command line tools like this, and you'll be able to do complex stuff immediately from the command line with no thinking. Because the Unix philosophy is build small things that work. And then if you want to do something more complex, pipe them, right? grep does regular expressions really well. It doesn't count so well though. But that's okay because we can take the output to one of these utilities, pipe it in, and that's what this is called. This is a pipe. It's a vertical bar. Why? Because, well, it's a pipe, right? It's going up, right? And we're going to pipe it as input to this other command over here, WCL 96. Was that correct? I forget. Okay. All right. All right. You could spot check any of the other ones, right? And just using command line tools like, say, awk is another great one. That reformats stuff. So, for example, do we have any book? No, I don't know how to do it with commas. That's okay. But in any case, there are a bunch of things like that. Another thing that you could do is unique zip codes, 10 million. Right? Oops. Nope, was that truly the unique one? And then sort it. 1, 2, 3, 4. Taking a little bit more time than ours. I don't know why. I know, because it's treating them because they're on different lines as unique. So let's sort zip codes, 10 million. Guess what that does? Exactly what our program does, but it does it at the command line. I could then pipe that, I could redirect that into sorted.txt, all right, and deal with the sorted ones, or I could just pipe it through unique. There we go. And this should not take that long. Wow. I'm surprised that it is so slow. But in any case, oh well. Yeah, there we go. It was way slower than my program. My program was way better than that, right? But there, you get all the unique ones. And then you can you can couple that with some regular expression and counter stuff in order to basically do this entire program here with just 2 or 3 or 4 command line tools. Right? All right, what I wanted to do with the rest of our time here is a speed run, maybe, through the 2021, excuse me, final exam. So that year, Scott Frost was still our coach, and he had this quote back in 1997. If you don't know any football history, that's perfectly fine. In 1997, this predates the playoff system, the FSB playoff system, in which it was the coaches poll and the media poll, etc. And basically that year, let me look at the output here, Nebraska and Michigan were both undefeated, right? And they never played each other, and they never would because they played in different bowl games. So there was a dispute on who actually was the national champion. If you look outside the stadium, you'll see Nebraska, 1997 national champions. If you go down to Michigan, you'll see the exact same thing on their stadium, right? So who actually won, or who deserved to win? And of course, Scott Frost, he was the quarterback at the time. He said that if you can look at yourself in the mirror and say that if your job depended on playing either Michigan or Nebraska to keep your job, who would you rather play, right? And so he's saying that clearly it was Nebraska that deserved to be sole national champion. What we're going to do is some data analysis to back that up, right? We're given a bunch of data, and we'll do this in Java because if you want to see the C version, watch the live stream from the main section. I do this same exercise in C. But in any case, what we're given is, and I gave it over here. Where's the team data? Teams and games. There we go. So here are the teams. The teams are identified with, do you remember what these are called? UUIDs, right? Universally unique identifiers. And each one is associated with a team that played they call them Power 5 now. I forget what the D1A back then was what they were called, Division 1A or Division A1 or whatever it was. Anyway, I've only got 145 teams here. Not all of these teams actually played a full season in this file over here. We only have 642 games because you have some teams in here like, for example, Nichols State, right? They played a full season, but as far as the teams that we're concerned about, they're kind of like one of those teams that come in the first 3 weeks that are gimme wins, right? And we'll never see them again. So what we need to do is we need to map this team, which is identified by a universally unique identifier, to a game. For example, who was the home team, or who is the home team for this game right here? If we look that up, I think it's Illinois. Yep, there's Illinois. Right? The next token says how many points they scored. Probably 2 field goals right there. And then they were playing an away team here. Right? And who were they? Oops, find that team, Ohio State. And they were crushed because Ohio State scored 41 points. Right? So we're going to have to bring these 2 different data sets together and produce this report. I want to know how many times each team won, how many times they lost, but I also want to know a point differential because I want to distinguish between these top 2 tier teams here. Nebraska scored 329 more points than were scored against them. That's why it's called a difference. Michigan scored 203 points against other teams than were scored against them. And poor Rutgers down here, other teams scored 305 more points against them than they scored that entire season. Right? So we're going to have to process these two files. Right? We'll do it all over here. The first thing that I want to do is I want to represent this data well. Right? And so I want to define a team. Right? What's in a team? What pieces of data am I going to have to keep track of according to, this over here and the actual data files? I'm going to need access to their name. If I'm going to be looking them up, obviously I need access to their UUID. So there are two things right there immediately, right? And the UUID is a string. Right? The name is a string. Right? What else do I need to keep track of? Wins? Losses? Do I need to keep track of the win percentage? No, because that's wins divided by total number of games. I also need to keep track of the point difference. So careful there. I'm going to process this game by game by game. So obviously I'm going to be incrementing and decrementing these values. Okay? So let's come over here and keep track of all of those things. Int wins, int loss, int points for, int points against. Because the difference is going to be points for minus points against. Right? You could, just have one variable there, the point differential, and then keep track of it. But I'm going to keep track of both of those. Okay. So in Java, what should I do at this point? Make a constructor, but before I even do that, oops, no, what is it? No, oh, this. There we go. I should make all of these private. And then make a bunch of setters, getters, a constructor, et cetera, et cetera. I will leave that as an exercise to you folks, right? Because I want to get this done before we only have 35 minutes here, right? So yes, this is bad practice to do it like this, to leave them all public, right? But we'll do it in order to get this exercise done here. Don't do that in your, in fact, you're not going to be able to do this because we give the class to you of whatever data we're having you process. Okay? But this is very much like C. If I were to do this in C, this would be a structure. Everything would be public, and we'd be in the same boat right here. Okay? All right, so the first thing I want to do is open up that teams file to find out my 145 teams. So file, F is equal to new file, and it's in the data folder, teams.csv. Let's bring that in. Oh, come on. Import, fine. My Eclipse has been broken as far as import suggestions for a long time now. Java.io.file. File, there we go. Okay, good thing I remember where it is though. Right? Now, to read from a file, I'm going to want a scanner. So, try with resources. Scanner S is equal to new scanner from that file. Now, this is Java, so I'm not really even going to be concerned about creating an array of 145 teams. Instead, I'm going to use smart data structures. Right? So I'm going to first of all ignore that first line entirely. No, come on, import. And it's in java.utils, I think. .scanner. Nope. Where is it? It's .util. There we go, singular. All right, and then no, catch, exception, rethrow, throw, new, runtime, exception, exception. There we go. All right, there we go. So I'm going to skip that first line. I'm just going to burn it, right? S.next line. Right? I don't even care that it's 145, right? Because this is Java. I've got dynamic memory that grows automatically for me, right? How do you want to? So the next line, of course, while S.has next line, excuse me, we will read the line is equal to S.next line. And that's a string. And that's going to look something like, well, exactly like this for the second line. There are 2 tokens there. How do I split the tokens up? Split along a regular expression. No need for a regular expression here, though, because it's comma delimited. Right? That gives me a array of tokens. Right? The UUID is the first token, and the name is the second token. There we go. Tokens, sorry. Now what do I do with them? I can create a new team. Right? So team T is equal to new team. There we go. But I want to give it the UUID and the name. At this point, I will go back and create that constructor. Right? But I'm not going to type it out. I'm going to generate constructor using the fields, and I'm not going to care about all of them. I'm just going to care about UUID and name. Great. Java will provide a default value for the rest of those integers, 0. Right? So we're good there too. C does not do that. If you need to initialize wins and losses to some value, make sure that it's 0. Okay? All right. So there's new team. Oh, saved it, sorry. And that should go away, right? What? Come on. Public, sorry. There we go. That should go away. Now, how do you want to store your teams? Remember, looking ahead here in the games, I'm going to want to, given this UUID right here, I want to look up Illinois. I want to look up Ohio State. What is a perfect data structure for me to do that with? A map. What kind of a map? Mapping what to what? Team map, I'll say. New hash map. I want to map a UUID to a team. Okay. Well, a UUID is represented in this program right now as a string. So map and hash map. Come on, really? Nope. Util. Everything's in util. So map and hash map. There we go. All right. Now that I've got that team map, what can I do? I could put team map dot put UUID mapping to that team. Remember, the UUIDs are guaranteed to be more or less guaranteed. With infinitesimally small probability, there could be a duplicate, but they're guaranteed to be unique for all intents and purposes. All right. Now I've got my teams. Now I need to do my games. All right. So let's come back over here and create. I don't need a map here because as I'm processing each line, I'll look that team up, add that points to their 4 points, look that team up, add 41 points to Ohio State, say that, oh, Ohio State won that game, so wins plus plus, but Illinois lost that game, so minus minus, right? And then update the point totals appropriately. So all I need to do is process this data. Let me go ahead and create a new file. F2, and that's going to be games. New scanner. Remember, I can do a new scanner right here because it is scoped to that try block because I'm using try with resources. And I don't need at the end to go s.close. Why? Because that's the whole point of using try with resources, that it closes it automatically for you. Okay? All right, same stuff here, except that it's not a UUID. It is, right? The UUID of the, what is it, away team is going to be tokens sub 0. It's always away and home, right? Okay. And away and home. That's going to be not the second one, but the third one. And then int away team points is equal to integer.parseInt of tokens sub 1. Right. And then the same thing, oops, but for the home team points in that one. If you want to, you can go ahead and set a breakpoint here and make sure that you're actually reading these correctly for the first line, second line, third line, etc. All right? But I have high confidence. We'll find out anyway if the report gets screwed up. What am I going to do with that data now? I actually need the home team and the away team. Those are in my team map. Equals team map.get away team, or UUID of away team. There we go. And, oops, the UUID of the home team. Now that I've got those teams, what can I do? I can award the points for each one, right? So for the home team, dot points for, right? They get their home team points. The away team, dot points for, they get their away team points. What else do I need to do though? What about, oh, yeah, go ahead. Ah, you're right. There we go. Home and away. So, in fact, I screwed up because I'm going in the wrong order. Away team comes first, and then the home team. Away team comes first, and then the home team. Right? Doesn't matter, right? But that's the way that sports work. Away team is always listed first. Now what? Away dot points against. How many how do I add points that were scored against them? The home team points, right? Home dot points against, there we go, is equal to away team points. Now before we take care of the wins and losses, what's wrong there? Yeah, plus equals, right? We're doing a running total here. We are not doing a reset them for each game, right? Then only the last game would matter. Right? Well, even under today's FSB, the games don't matter.
For this scanner, do you need to have the second file in there?
Oh, sorry. Yeah, right there. It's
So, like, in your scanner and your tries.
oh, thank you. That one, F2. Thanks. Otherwise, we would have seen that immediately when we first tried to run it. Yep. Okay. Good. Now, what about the wins? There are no ties in there are no ties in football. There are. Even in professional football, you can have a tie. Away points, away team points is greater than the home team points. There's not in this data set, though. I can guarantee you that. So who won the game then? The away team. So the away team dot wins plus plus. Just one win. What about the home team? They lost plus plus. All right. Else if, just the opposite here, the home team won. So how do I handle that? There. Now we can print it out and make sure that it actually works. So for team, T in team map dot values, right? That saves me the need of looking at the UUIDs. I'm just going to get everything that they map to. System.out.println T. All my processing looks good because I don't have an exception here. But what does that mean? I don't have a toString method over here. That's okay. And this should actually go down there. It produces, it auto-generates code wherever your cursor is. So be careful. Let's see, generate source toString method. Yeah, we'll go ahead and generate it. It looks like this initially, at least. I don't like that. That's ugly. So let's go ahead and return string.format. And then we want this format right here. The name, the wins, the losses, and then the percentage and the point differential. So double win percentage is going to be this dot wins divided by this dot wins plus this dot loss. Right? And now let's format that. There's the name. Let's go ahead and align everything with 20 characters. And then percent 2D, percent 2D, that's going to be the name, not names. This dot wins, this dot loss. And then I'm going to want to output the win percentage there in percentages. And I think that we only had 3 decimals of accuracy. Usually it's only 3 decimals of accuracy. And it is reported on a 1-point scale, so 0 to 1. Okay. Let's come back over here and see if we've got at least that data there. Okay. Almost there. There's wins, losses. Where's Nebraska? There we go. 11-0, 100%. Who else should we look at? K-State? 10-1. Uh-oh. 0%? Okay. Back to the drawing board. Win percentage. It's a double. So why isn't it printing as a double? Yeah. Both integers, and therefore integer truncation. Make one of them a double. Okay. What else do we need? A point differential. So let's go ahead and put that into a variable. Int point diff is equal to this dot points for minus this dot points against. And we'll print that out last. Percent D. There we go. In fact, let's go ahead and do it with 4 columns there and point diff. All good. Run it again. Okay. Looking better, looking better. I don't know what Iowa would be. We only saw the top or whatever, so Kansas State. 224 and 909. 224 and 909. I think we're almost there. Except that, tell me about that report. Does it look like, I'll go ahead and shift it over there. Does it look in order? So now we need to sort it. That seems like a pretty complicated sort because we're going to be looking at the win percentage, and so we have to compute that. Then we're going to be looking at the point differential if we see a tie. So I'm going to make a full comparator here. Right? Comparator for team. CMP, the only one. Right? Don't call it that. Think of a better name though, eventually. Is equal to new comparator. By the way, remember that on code post, you're going to have to put it over there. You can't use elision there on code post, right? Come on, bring it in. Fine. Where's it going to be? Utils? Nope. Oh, no, it is. Okay. So now I just need to generate the unimplemented method here, the compare. Comparing team A to team B. How are we going to do it? Well, first of all, let's do the win differential. So A dot wins divided by A dot loss plus A dot wins, right? In the denominator there. Man, I've already done this code before, haven't I? I don't want to have to rewrite it. So let's come back over here to the team class here. And you know what? I don't want to have to write that code over and over and over again. So let's go ahead and put it into a function, double, get win percentage. Right. And return that. That way I can actually use it in my class. What was it? Double win percentage is equal to this dot get win percentage. Not only that, but now that it's public, I can go ahead and use it over here, right? So A win percentage is going to be equal to that. B win percentage is equal to that for B. A dot and B dot. I forgot to declare my variables. What types are they? Doubles, or they can be vars. This is something that was added in Java 10 or 11 or something like that. It is very bad practice in my opinion, and something that should not have been added to the language, but they saw another language, C#, doing it, and they thought, hey, cool, that's new and shiny, let's do that too. What it is it is a variable declaration, meaning that when you create this variable, what it's going to do is it's going to look at the type of value that you assign to it and go, oh, that's a double. I'll go ahead and magically change this to a double for you, right? The problem is, if you ever try to, you're doing it right on this line. You're not saving typing, right? You're saving 3 characters there. And you're only making problems later on down further in the program to do this. So you might see this eventually. Stay away from it is my opinion. Right? If A's win percentage is greater than B win percentage, B win percentage, are they in order or out of order? Remember that I want the best win percentage at the top. So A comes before B, and I return what? Something negative. Right? Else if A win percentage is less than B win percentage, then I will return something positive. Else, now I've got a tiebreaker, right? They have the same exact win percentage. Now what do? Int A point diff is equal to A dot points 4 minus A dot points. Again, hey, this sounds familiar too. Didn't I write this crap too? Yeah. I wrote it right there. What should we do again? Put it into a function. Public int get point diff differential. Return this. All right, and int point diff is equal to this dot get point diff. There. Question online? Oh, hello. Yeah, go ahead.
Are good practices like taking account for days at all? Or is it just
The usual stuff from a hack. So you need your documentation, you need good spacing. I don't know if I've got good spacing. There, now I've got good spacing through magic. The usual stuff on a hack would be, for design, would be no obvious memory leaks, no dead code, et cetera, et cetera. Right? As far as object design, I'm going to tell you right now that we give that to you so to save you time. Okay? So we would have given you that team class right there. Right? All right, so A dot get point diff. There we go. Int B point diff is equal to B dot get point diff. And here I'm somewhat safe in doing the difference trick. Let's see. B point diff minus A point diff. There we go. Right. I'm comfortable with that because there's no way that an NCAA team would score 2 billion points in a season, resulting in an overflow there. Right. All right, now all we need to do is what? Sort it. Collections.sort, and actually I need to dump them first. Teams is equal to a list of teams, right? And that's going to be team map.values. There we go. Oops. What am I doing? Teams is equal to, there we go. Yeah. And it's broken, so I don't know why. I'm just going to reinstall Eclipse at some point here, after it's all over. All right. Or what are you complaining about? Okay, it just returns a collection, so we have to do a new array list. Remember that that's going to be doing a deep copy. If you wanted to copy one list to another list, you can make a deep copy there, or collection to another collection. Come on. Really. Array list. There we go. Now I'm going to be sorting teams. How am I going to be sorting them? By that comparator that I just wrote. Right. Now let's see if it works. Who is the best team? Oh no, darn it. Oh, because I'm still doing team maps. Sorry, teams. All right, so clear this out. Let's run it one more time. Looks like the best teams are at the top, right? Wow, Youngstown State. They're third. I actually do like that. K-State's nowhere near the top. K-State, yeah, go down. Right. Youngstown State was definitely better than Florida State or whatever. So what are we doing here? Unfortunately, we're including these lower tier teams. I don't want to say bad teams. I have no idea who they are. Southern Utah, right? What we want to do is we want to only print them out if they have 10 or more wins, or 10 or more games, I should say. So if T dot wins plus T dot loss is greater than 10, greater than or equal to, maybe, I don't know, greater than or equal to, then we'll go ahead and print it out. There. Clean it up. Run it. There we go. Nebraska, Michigan, Florida State, Kansas State. Does that look like that? 203. Yep. What about the very, very bottom? We've got, 249. Oh, I guess they were 0 and 11. Okay. So, oh, there we go. We got more down there. Rutgers is 305. Rutgers is 305. It just was on the next page and I didn't see it. Right? Okay. 9 minutes left here. How could we improve this even more? In fact, when I was writing this comparator, I was doing a whole bunch of manual calculations and realizing, wait a second, I already did this calculation. I did this calculation over here and I put it into a function. Well, do I have to write this entire comparator the way that I did now? Because I've got functions to do this. Compare it first by win percentage and then compare it by the point diff. If you put those into functions, guess what you can do? Comparator dot comparing team get win percentage, and all that boilerplate code of if conditions is taken care of for me. Dot then comparing team get point diff. Was that right? What did I call it? Get point diff, yeah. What are you complaining about then? Oh, you're just complaining about the semicolon, fine. Right? And you can chain these things. So I'll go ahead and go to the next line there, right? How much easier is that, right? Because I put it into the team over here. In fact, now I'm even thinking more object-oriented programming. Shouldn't a team know how to orient itself relative to other teams? Right? Remember the trick of implements comparable to other teams? I could take all that logic that I just erased and I could put it into this class. And then I wouldn't need a comparator here at all. And I could simply do that. Sort it. Right. We have enough time. Do you want to see it? All right. Add unimplemented methods. There we go. There it is. And then I'm going to have to undo to get all my old like my old implementation that I just erased. Or I could compare, where is it? Compare with local history. What, 5 minutes ago that was? 4 minutes ago? There we go. There, I added the list. Nope. Oh, there it is. Over here on the right. I'm going to grab all of that logic, copy it, come over here to the team class, A should be this. B should be that. This. That. Now it is comparable. And I don't need any of this stuff. I'll leave that in there though. I don't need that right there. Right? Simple code. That's one of the cruxes of, or that's one of the basic tenets of object-oriented programming. You're wanting to compare teams. That sounds like a lot of logic. Where does that logic belong? In the team class, right? You want to compute a win percentage based on a team's points for wins and losses. Where's wins and losses stored? In the class. So what should you be doing? Putting it in the class, right? All the heavy lifting should be done in the classes and not here in the main code here. Right? In fact, I would even refactor this to have like is relevant or something like that, or is division 1A or whatever, right? All right, 5 minutes left here, right? And this still works, by the way, I hope. Husker report. Yep, Rutgers is still at the bottom, Nebraska's at the top. So 5 minutes left here. Remember that it's on Tuesday. It will open up Tuesday morning, 1 minute after midnight, so 12:01 a.m. It will close 1 minute before midnight on Tuesday. You will have something very similar to this where you've got to run a bunch of reports on a bunch of data. We will give you plenty of starter code. You'll do the exercise in Java, you'll do the exercise in C. Order that you do it it doesn't matter. You'll have two hand-ins on code post. You can submit and resubmit as many times as you want up until the due date at midnight. It's designed for 2 hours, so it's probably a little bit longer than other exams. Plan ahead. You can do it anywhere. I'm not going to be here. LAs are not going to be here. If you have a technical problem with your computer or anything like that, the lab is open 24/7 with your key card access. So you always have a working computer, and there are people here to take care of computer issues. So you always have a working computer to work from. Otherwise, you can take it wherever you want. No collaboration with anybody. You can post to Piazza questions, but do not post any code. We didn't have that problem in this section, but in the main section for the second exam, we had like 3 or 4 people posting their code saying, it doesn't work, it doesn't work. And I had to shut that down really quickly. Like, why are you doing this during an exam, right? It was okay because I didn't do anything like donk them for cheating or anything because they were posting bad code. So if you want to use your bad code, go ahead. Don't post anything. If you do post a clarifying question, right? Be judicious about it. We will answer clarifying questions, but we won't necessarily give you the same level of help as a lab or a hack or something, right? Some end of semester stuff. Make sure that you are filling out that course evaluation. I haven't looked at it recently, but if we hit 75%, I'll give bonus points to everybody on that. Today, as of 4:30, is your last opportunity for 2 hacks, 1 lab resubmission downstairs. Do it if you're going to do it this morning, because I can imagine this afternoon we're going to have a whole bunch of people that waited to the last minute from the main section coming in and maybe not getting something checked off. It's been very, very light. I don't know why. So with that in mind, any questions in the final week? Anything? No? All right, then have a good break.